So I just wanted to go over a little bit of why we do this thing with radians in the first place. And the thing with radians in the first place helps us a lot when we deal with circular motion. It helps us in physics, and which is near and dear to my heart. When we talk about velocity, or we talk about straight line speed going in a certain direction, that's velocity. We talk about the displacement, how far it's gone in a certain period of time, and we try and boil that down to meters a second because that's the standard unit of measure in physics. But what I really want to see if we can discuss right now is what happens when we're moving in a circle, right? Well, we need to know how far around this wheel is. If this wheel makes 2 revolutions a second, then I want to know how far we've gone. Well, I don't know, right? But the first thing I need to know is its angular velocity, how many revolutions it's gone around in a second, how far it's gone circular-wise in a second. And I say, how many times does it roll over in a second? And so we use the radians, right? We use the radians because it tells us, a lot of information. And then we can multiply that by the radius and we'll see it. And that all goes back to, this wonderful thing that they found was circumference is equal to 2 pi times r. That's the whole linear distance around a circle, right? That's the circumference of the circle. 2 pi, which is all the way around the circle, times the radius tells me how long this line would be if I cut it right here and stretched it out in a big long line. So I want to know how far I go around in a certain amount of time. And I said this wheel goes 2 revolutions a second. Okay, well, if 1 revolution all the way around in terms of radians is 2 pi, and that's what I showed you before, right? 2 pi is 1 complete circle, 2 pi radians. If it goes around again, that's another 2 pi. So it's gone around 4 pi radians in a second. Well, that's cool. That's 4 pi radians a second. That's great. And that tells me that my angular velocity, or my angular speed, my rolling speed of this wheel, it goes around 4 pi 2 times in a second, or 4 pi radians in a second. Well, with that, I can find out what my linear distance is, or my linear velocity is, because this s here is what the length of the arc is of my angle in radians, and that's my angle. That's my angle in radians. It's 4 pi. It's gone around twice. It's 720 degrees. It's gone around twice. So that's my angle in radians. So I take my angle in radians. This s is really my angle in radians times the length of the radius. And let's just say my wheel is 0.5 meters, or 1 meter across, or half a meter in terms of radius. Well, that's going to be great, because if I multiply this 4 pi radians per second, I can find out what my linear speed would be, or my linear velocity would be, if I just multiply it by what the radius is. That's what it says, right? Okay, well, then I take my 4 pi and I multiply it by a half, and then I say, well, it's 2 pi. 2 pi, times 1.5 meters equals 2 pi meters a second. And here's where it really falls off the rails, right? Wait a minute, didn't you just say we were radians a second times meters? Well, what about the radians? Where does that go? And unfortunately, as soon as you move this to straight line motion, you immediately adopt the unit of length and drop the radians. Unfortunately. So I apologize for that nonsense, but we do end up with 2 pi meters a second. If you wanted to do that math, you could say it's 6.28, approximately 6.28 meters a second, which is not so bad, right? Not as fast as Usain Bolt, but pretty fast in and of itself. And that's the whole idea behind this. If we wanted to find a straight line motion, we take however many radians this object goes in a second, or in whatever unit of time you want to measure. And then we multiply by the length of the radius, and now we know what our linear velocity would be. It's a very simple idea. It's a very simple concept. And that's why we learn the unit circle for certain ideas, right? The other ideas are going to come to us when we start talking about the sine, the cosine, and the tangent, and the secant, cosecant, and cotangent. But for right now, I just wanted you to understand that this does have implications in the physical world. And we see it every day when I get in my car and I drive away. I could, if I felt like it, and I don't, if I measured the radius of my wheel from the center all the way to the outside, the very edge of the tire, I could find out how many revolutions it takes to get home. Would I want to? No, but I could, because it does exist. All right? So that's why we do it. All right, thanks for your time. And this was just informational. There's no work that goes with it.